This is the Creativity in the Future series. If you'd like to join us on social media, the hashtag for the series is CreateEDU. There are a number of events coming up. This is intended for administrators, teacher leaders, and trainers as the primary audience. And it's to discuss the importance of creativity, the nature of it, and how to really develop it in the classroom and the educational settings. You can see some of the upcoming topics include, for October, does creativity matter in the world of work? And then there's one each month. And the following topics are the ones that progress from there. Bringing innovation to school. Who's telling your story? Teaching for creativity in the Common Core classroom. How do you do it? Insights from school administrators. And then we have a series of Ignite talks in March. What does creativity in education look like to you? And then in April, we round out with the future of digital learning. I'd like to introduce our speaker today, Dr. Mitch Resnick. He is a professor and he works with MIT Media Lab. I think it's time to bring him in and let him do his magic. So I'm going to shift over. Mitch, are you with us?
Yes, I'm here.
Wonderful.
Yep, great. Okay, well, thanks a lot, Kelly, for the introduction, and thanks to you and Thor for helping to organize all of this, and special thanks to Adobe Education for sponsoring this event. It's on a theme and a topic that's very near and dear to me, so it's great to get a chance to talk with all of you about it. As Kelly mentioned, I titled my talk, Sowing the Seeds for a More Creative Society. And I want to start by focusing on that word creative. Why is it that we should have a goal of a more creative society? And I think that even though people have all sorts of different visions and goals for what society might be like, one thing that I think almost everybody could agree upon is that the world is changing more rapidly than ever before. I think we just see this in our everyday lives. And we know that specific things that we learn today might be obsolete tomorrow. But the one thing that will always be needed is the ability to come up with creative solutions to a rapidly changing world. Because as the world keeps changing so rapidly, it's really essential for people to be able to come up with innovative solutions to the uncertain and unpredictable situations that they'll be confronting. So in our research group at the Media Lab, we've been thinking a lot about how can we help people and young people get prepared to thrive in a society that's changing more rapidly and will value creative solutions and creative activity more than ever before. As we've looked around for inspiration, we've gotten a lot of our inspiration by looking at kindergarten. In fact, my own research group at the Media Lab is called the Lifelong Kindergarten Group because we've taken our inspiration from the ways children learn in kindergarten. So as you see in the picture here, this is my image of a prototypical kindergarten. And I think if you look at a typical kindergarten, you see kids constantly, designing and creating things in collaboration with one another. They might be building towers with blocks, as you see the kids on the floor here, or making pictures with finger paints and crayons. And in the process, kids are learning a lot when they mix colors together with finger paints. They learn how colors mix. They build towers. They learn about stability and structures. But maybe most important, they're learning about the creative process. And we have to remember that create is at the root of creativity. So we think it's so important to give kids the opportunity to create. And that's what we see in the traditional kindergarten, where kids are creating towers and pictures and images in collaboration with one another. And I think we want to try to take that approach and extend it to learners of all ages. Because we see it as a problem that too often after kindergarten, education turns from an image like this to an image like this, where somebody's just delivering information to the learner. And too much of school after kindergarten is set up in this type of transmission or delivery model of education, of thinking that we need someone to deliver information to the learner. And we don't think that's going to be the best way to prepare young people for today's society. And we know that we have to make this shift in order to prepare people prepare people for a creative society. And how is it that we can make this shift? Well, part of it is, we think, through the design of new technologies. In fact, The traditional kindergarten has lots of materials and technologies. Wooden blocks and finger paint are types of technologies. So we want to see how can we use new technologies to stretch that kindergarten approach. Plus we know that blocks and finger paint are great for learning kindergarten concepts like number and shape and size and color. But we need to have different types of tools and technologies and media if we want to extend that kindergarten approach to learners of all ages. When I look at my own laboratory at the Media Lab here at MIT, we see it as a big kindergarten. And we have lots of new technologies like laser cutters and 3D printers. But the key to the success and the innovation of the Media Lab is not the technologies, but the creative ways we use them to allow everybody to design and create. So giving that opportunity to create is really the key to the creative process. Let me be a little more specific about some of the ways that we're trying to use new technologies to move away from this image of delivering information to a more kindergarten approach to learning. So like one project we've worked on for many years is a collaboration with the Lego toy company where we've been adding computation to Lego bricks so that kids can build not only structures and houses and castles as they do with traditional Lego materials, but to build things that move and interact and communicate. So with new Lego robotics kits like Lego Mindstorms and Lego WeDo, kids can make things that come alive. And we see this, although it's intended for kids beyond kindergarten, it's using that kindergarten style of learning, where kids are using these new materials to build robotic devices, to move and react and interact with one another. In fact, the picture here, this is of the National Junior Robotics Champion from Singapore. When I was visiting Singapore, they introduced me to him, and I was very impressed with what he was developing. Not just the performance of the robot, but more how he was able to come up with creative solutions. When I asked him, well, how might you change your robot to solve this other task or to do some other, to meet some other requirements? And he was very creative in coming up with new solutions. So I saw how he was developing as a creative thinker, but I also saw some of the challenges. When I talked to his teacher, I was explaining that I was impressed with what he was doing, and I asked her, I wondered, how did they integrate this into their classroom activities? And the teacher looked at me like I was crazy, and she said, we would never do this during the school day. The school days, they must, work on their math exercises. This is for after school. And I think that's a common problem, that people think, well, during the school day, it has to be for drilling on your math exercises. In my mind, the type of activity that he was doing in building these robotic devices should be the essence of what all of learning is about, both inside of school and outside of school. It's great that he had the opportunity to do this out in an after-school club at the school, but I think this is what all of learning should be about, giving kids the opportunity to use new materials to design, create, and develop as creative thinkers. Now, of course, with materials like this, kids are building things in the physical world. But we know that kids today also spend a lot of time online in virtual worlds. And we want to make sure that as kids spend more time online, they're also having the opportunity to design and create and express themselves. Because we get concerned that kids spend a lot of time online and all they're doing is browsing and chatting and playing games and not having an opportunity to design and create and express themselves. What's really needed for them to develop as creative thinkers? So one thing that we've done is we developed some new software that's called Scratch. This is a programming language that allows kids to create their own interactive stories and games and animations and share their creations online. So again, the same way that kids in kindergarten will create with wooden blocks and finger paint, and the way that kids in robotics activities will create with Lego Mindstorms, kids can use Scratch to design and create interactive stories and games that they share with one another. Let me show you a video that gives you a sense of how it is that kids create with Scratch. You create the programs by snapping blocks together, much like snapping Lego bricks together, to give the behaviors for each of the characters. In this case, he was creating a game where a big fish eats a little fish. Now, after he created this game, he could also click on the share button to share his creation with others. And I think that's really at the core of all the creative processes, the ability to create things and then share your creations with others so you can get feedback from others and to learn from others in the community. I think what I'll do during the rest of the talk is to focus on a collection of stories to give you a sense of how it is that kids are using the Scratch software and participating in the Scratch online community in order to develop as creative thinkers. And hopefully through these stories you'll start to get a sense of some of the processes that are involved with developing as a creative thinker. So the first story I'm going to tell takes place around Mother's Day. And the story started, it was a couple of years ago, it was in the month of May, and it was the day before Mother's Day. And suddenly I realized that I hadn't gotten anything from my mom for Mother's Day. So I started thinking, well, what could I do as a last-minute gift for my mom? And I started realizing, well, maybe I could make her an interactive Mother's Day card using our Scratch software that our group had been developing. But before starting to develop my own Mother's Day card, I decided to go to the Scratch online community. So I showed how kids can click the share button and share their projects. When they share it, it goes into this online community, and there there's more than 6 million projects that kids around the world have shared. Every day there's 10,000 new projects. It's a very active community. So I went to the online community and I typed Mother's Day into the search box. And I was delighted to see that there was lots and lots of projects that were there that were interactive Mother's Day cards. So as I looked at them, I noticed, first of all, that many of them had been created just in the past 24 hours by procrastinators just like me. Kids who were making Mother's Day cards at the last minute to give their mom. So I started to look at some of these to get a sense of how kids were creating with Scratch. So here's one animation that was made by a 9-year-old in Scratch. So it's an animation of a cat wishing Happy Mother's Day to the cat's mother. And then very generously offering a replay, because you know that mothers are going to want a replay. Here's another example that we saw. This one was made, I think, by a 12-year-old. This was an interactive Mother's Day card that starts out with the letters Happy Mom Day, but then as you drag your mouse over the different letters, it reveals a Mother's Day message. I love you and care for you. Happy Mother's Day, Mom. And there it goes. So again, a very nice Mother's Day card, interactive Mother's Day card. And I'll show one more example. This one is more of a story that someone created about Mother's Day. And it's a story where it says, oh hey, this morning someone told me it was Mother's Day. I Googled and found out it was true. Now I have something to say to you. I love you so much. This much, and then ends up with a little cartoon graphic of the family. So when I saw these examples, I was very happy to see these because in my mind, this really lived up to the vision that we had when we created Scratch. These days, there's a lot of talk about learning to code, and people are saying it's important to learn to code. But sometimes I feel that people are focusing on the wrong things. They sometimes focus on learning to code as a pathway to a job. And of course, there are great job opportunities and career opportunities in learning to code. But when we help kids learn to code through Scratch, we had things more in mind like these Mother's Day cards. We want to let everybody learn to express themselves with this new technology. It's not just for kids who might grow up to become professional programmers or professional computer scientists, but we think it's important for everybody to be able to create and express themselves. The same way that it's important for everyone to learn to write. We don't teach writing just because some people will grow up to become professional writers or novelists or journalists. We think everybody should learn to write because it allows you to express your ideas. Also, learning to write helps you refine your thinking and organize your thoughts. We think the exact same is true with coding. The coding allows you to express your ideas in new ways, to be able to come up and create things and develop as a creative thinker. So again, we want everyone to have the opportunity not just to point and click and browse online, but to create online, as they're doing here with creating a Mother's Day card. Because by creating things, as we've seen in these Mother's Day cards, that's the way people will be developing as a creative thinker, to be able to come up with new approaches, to learn how to take a complex problem, divide them into simpler parts, to be able to take an idea, refine it, share it with others. So I was really so happy to see that these kids were using the computer not just for browsing, and also not just for learning to code, but also for expressing their ideas and learning to create with the computer. I should finish up this story by letting you know that I never ended up finishing my own Mother's Day card. Instead, what I did was I sent my mom links to about 10 Mother's Day cards that I found on the Scratch website. And fortunately, my mother reacted just as I hoped she would. She wrote back to me and she said that I'm so proud to have a son who created the software that allowed all of these children to create Mother's Day cards for their mothers. So my mom was happy. That made me happy. But what made me most happy was that kids were starting to learn to create and express themselves creatively with the new technologies. So let's move on to story number 2. And story number 2 talks about one particular member of the Scratch Online community. This is everyone that joins the Scratch Online community, and now there are more than 3 million people who have joined the community. Everyone, can register their own username. So this is the story about one young girl. She started when she was age 12, and she chose the username Red Neptune. And I want to share with you some of the projects that Red Neptune did as part of her work with Scratch and on the Scratch Online community. So I'll start with one of the very first projects that she did when she joined the Scratch Online community. And she started out by making this holiday card to send to her friends. Okay, here, so this was, and when you click on each of the reindeer, each one plays a different part of the song. So when I saw this project, I thought this was great. It was really, again, the type of thing we were hoping that kids would start creating. Because, again, she was creating with an audience in mind. She made this project, and then she posted online and sent a link to her friends, so she was able to have this interactive holiday card to share with her friends. So this project was very impressive. But what Red Neptune did next is what really took us by surprise. This first Christmas card, we were impressed with it, but we weren't so surprised. The next thing really took us by surprise, because what she decided she liked best was, instead of making entire cards or entire stories, Red Neptune decided what she liked most was making individual characters. So she started making projects like this one, where she just started showing off and presenting some of the interactive characters that she was creating. As you'll see here, she made, we call them sprites in Scratch. She made everything from galloping horses to dragons to dinosaurs. What's important is, in addition to creating these, in the project notes she said, if you're interested in any of these characters or sprites, please feel free to use them in your own project. If you want to use something different, if you want a different character, write a comment below and I'll make it for you. So basically, Red Neptune was offering her consulting services online. And we just never imagined anyone doing this. So she was not just using this as a creative outlet to show off what she had done, but also a way to offer her services so she could contribute to others. And sure enough, other kids started making requests. So on the next slide, we can see a project that she created that someone said that they were making a game that needed a cheetah. So they asked Red Neptune, could you make a project for us with a cheetah? So she went to a National Geographic website, found a video of a cheetah, and then made her own animation of a cheetah. So again, she made the drawings and then animated it with the blocks in Scratch. Someone else said that they wanted to have a bird with flapping wings for their project. So she made a bird with flapping wings. And that was good, but the person who would ask for the bird said that although they liked getting this, what they really wanted was they wanted to learn how to do it themselves. They wanted to make their own bird with flapping wings, not just to use one created by somebody else. So then my Red Neptune made a tutorial project that showed how to create a bird with flapping wings. So here you'll see this step-by-step tutorial where she shows how she drew the wings, and then she shows how she animated it and wrote a program to make the wings flap. Now, when we created Scratch, we figured that we would be making some tutorials to help people, learn how to do things. And we thought maybe some teachers would make tutorials. But what really took us by surprise was the fact that young people, like my Red Neptune, started making tutorials on their own. And there are now literally thousands of tutorials online. There are entire galleries with hundreds of tutorials made by kids from the Scratch community. Everything from how to draw and animate a wing, to how to make scrolling backgrounds in your games, to even how to make your projects popular in the Scratch Online community. So we've really seen kids mixing together their creative activities with the community. And I think so much of creativity these days, it's important of how you integrate with the communities that you're part of. And we see that happening in the Scratch Online community, where kids are learning how to express themselves creatively as part of a community. I'll show one more example of how my Red Neptune collaborated with others. In this case, there was a game that she worked together on with 5 other young people from 3 different countries, and they worked together on this adventure game. My Red Neptune made the main character. Other people made the background. Someone did the story. Someone else did the music. So together, they made this animated adventure game. So we see this as one of many ways, that kids share with one another, in the Scratch community. We've seen with my Red Neptune, she was sharing her creations online so that other people could play with them, like the Christmas card. She was sharing by offering her services to make different characters for others. She was sharing by doing tutorials for others. And she was also sharing by collaborating directly on these multi-person authored games. In fact, with her fellow authors, they made a company they called Crank Inc., made their own website about the company. So they're really learning to share and collaborate in so many ways. And again, we see that as a critically important part of the creative process. Even going back to that picture from kindergarten, we see kids working together on projects in kindergarten, and that's an important part of the creative process. It's not just making things yourself, but making things, sharing with others, getting feedback, and then constantly iterating and improving based on what you've learned from others. Now, with the examples we showed so far, the story about Mother's Day and the story of my Red Neptune, these were done by kids outside of traditional school settings. But we also see it's important to bring these ideas into school. So my third story is about Scratch Goes to School, and I want to let you know about some of the ways that Scratch is being used in schools to help kids work on creative projects in schools. The first project comes from a school in Bangalore, India. And in this school, the kids were they were studying in science class the different layers of the earth. And as a final project, one of the students made this project where he gives a guided tour to the different layers of the earth. As you'll see here, as he goes down, he gives a guided tour. That's his voiceover in his native language of Kannada. And he's sharing what it is that he's learned about the different layers of the earth. His teacher explained to us that one thing the student was really excited about was to learn that there were things moving inside the earth. He was shocked that things are moving. So he really wanted to emphasize things like the water table that the character is coming down to show that things are moving inside the earth. With sound effects and everything. So again, typically in the past, and when a class was studying the layers of the earth, they might have written a final report or maybe a PowerPoint presentation. But now, kids are able to make a dynamic, interactive presentation where they can put themselves into it, put in their own voice, their own media, be able to share their ideas so that others are also able to learn from what they've learned. The next example comes from a middle school in New Jersey where they were studying the island of Rapa Nui. Oh, sorry, this is a different one. This is from an elementary school. Sorry, I jumped ahead. This is an elementary school in Minnesota where they were studying the book Charlotte's Web. So as part of their English class, they were doing book reports in Scratch. And here you'll get a chance to see how one of the students did a book report on Charlotte's Web. One thing I like about this is how it crosses over traditional disciplines. Although this was done for an English class, in order to make the pig move back and forth and scale larger and smaller, the student had to be using mathematical ideas about scaling, multiplying by different numbers to make the pig bigger and smaller. The student also had to be using ideas from art class about perspective. To make something look further away, you make it smaller. So in this project, they're bringing together ideas from English class, math class, art class. And I think the most creative learning happens when we cross over those disciplinary boundaries, not just get stuck in an individual discipline. So we're always looking to see how can we help people build on their own interests and cross across the different disciplinary boundaries to be able to express themselves in new ways. A final example from school, and this is the one that is where a middle school where they were studying the island of Rapa Nui, or Easter Island off of South America. And in this case, the student made a type of Sim Rapa Nui, sort of like Sim City, but for the island of Rapa Nui. And it was using what he had learned about the culture and the history of Rapa Nui. He had learned that fishing was central to the economy. So in order to succeed in this game, you have to cut down a branch to make a fishing rod, go out and fish. You might see there's a label here for God happiness. If you cut down too many trees, the God happiness goes down. So it's all based on what he had learned. So it's a way that both he was able to share what he had learned about Rapa Nui, but also to help other people learn about Rapa Nui. So I think we've seen in these examples, one was from a science class studying the layers of the earth, another from English class, a book report on Charlotte's Web, here from social studies class. But in all of these different classes, the kids are, again, learning to express themselves creatively, cutting across disciplinary boundaries in order to not just learn the content of the discipline, but also developing as a creative thinker, learning how to start with an idea, share the idea with others, refine your ideas based on feedback from others, and be able to, come up with a final project that other people are able to use. These ideas of how people can express themselves creatively in schools is one thing we want to support. And one of my former graduate students, Karen Brennan, who's now a professor at Harvard Graduate School of Education, has started a website called Scratch Ed, Scratch for Educators. So whereas the main Scratch website is for young people, where young people share their creations with one another and also get feedback to one another, the Scratch Ed site is one where educators come together to share their experiences, to share lesson plans and curriculum guides, to share assessment rubrics of how they're evaluating the use of Scratch in their classrooms. So if you Google Scratch Ed, you can find the Scratch Ed website, and again, there's more than 10,000 educators who are sharing ideas. I should mention both the Scratch website and the Scratch Ed website are both free. We want to make these free and open to everybody, to young people everywhere and to educators everywhere. We also want to be very international. The Scratch website itself is translated into more than 50 languages. So as kids create their projects in Scratch, the programming blocks are translated to many different languages. So even if a student in Boston creates a project in English, a student in Tokyo can look at the program in Japanese, or a student in Buenos Aires can look at it in Spanish. So kids around the world can work together on their projects. The fourth story I want to share is about connecting to the world. Now, I've mentioned that kids spend a lot of their time online these days, and Scratch is great for kids to be able to design and create in the online world. But we still like the physical world a lot as well. Kids grow up in the physical world. They have great intuitions about the physical world. They're still going to live in the physical world. So we want kids to be able to think about designing in both of the worlds, both designing in the physical world and designing in the online world, because we really think to become a creative thinker in today's world, you need to be able to think in many different media, in many different contexts. So for that purpose, we've extended Scratch so that kids can program Scratch not just for controlling their animations on the screen, but also to control and get input from things in the world. So first I'll show a video that was from a group that made a physical interface to control a game that they had created in Scratch. This was using a board that we call the Scratch board that can detect, has a light sensor on it. In this example, they made this physical wooden model saw. As they move it back and forth, it can detect, the sensor can detect the motion, and it then controls the movement on the screen. So the sensor, the light sensor, can detect the holes in the board as it moves back and forth. The board then sends a signal to the program, and then the program has the characters move back and forth to saw down the virtual tray. So in this case, the young people who created this were having two types of design experiences, both designing the program on the screen in Scratch, but also designing the physical interface that they're using to control the game. And we think that we have multiple experiences of creating things, you get a better understanding of that creative process. I'll show one more example. This is linking Scratch with the Lego We Do Robotics kit. This is a robotics kit from the Lego company that has several different types of sensors. And in this case, this is from a workshop at the Science Museum of Minnesota where kids were making games with Scratch and then controlling it with the We Do sensors. In this case that we'll see in the video, it was a car driving game, and they used the tilt sensor from the We Do kit to make a steering wheel. So as he moves the steering wheel, the tilt sensor detects how it's tilted and controls the car. There's a distance sensor here that can tell how far away it is from the wall, and that controls the speed of the car.
After we go over a couple of things about script writing.
So again, this is a way that he's able to both create in the physical world to control things in the virtual world. And again, we see in the future, the virtual and physical worlds become more and more interwoven, and we want to help kids grow up seeing ways that they can be in charge of creating things in these worlds. We know that kids are going to be interacting with these physical digital combinations all the time. We see it already. Kids walk up to a door, it opens automatically. When the sun goes down, lights come on the playground automatically. But we don't want this to be magic. We don't want kids just to see these automatic robotic activities as if they're magic. When kids get a chance to create their own interactions, they start to get a better understanding of the way things in the world around them work. And we want kids to see themselves as ones who can create things in the world and understand things in the world. And we want to give them the tools so they too can be the creators. I know these days, oftentimes, if you go into a toy store, there are lots of toys these days that combine computation with physical devices. There's a doll, and if you start, poking its belly, it starts singing, or you start waving to it, it starts dancing. And it's very, very sophisticated technology, but all that the kids are doing is interacting. We want kids to go beyond interacting to creating. If they really want to develop as creative thinkers, they need to go beyond just interacting with these interactive devices. They need to start creating, as we've seen in these examples. For my final story, I'm going to talk about another way of stretching Scratch. In this case, it's not stretching it to the physical world, but stretching it down to younger kids. Over the last few years, my research group here at the Media Lab has been collaborating with a research group at Tufts University, Marina Bears' group in the Department of Child Development there, and also with a company, the Playful Invention Company. We've worked together on a version of Scratch called Scratch Junior. It's meant for younger kids, starting from age 5. Because we see that if kids start reading and writing at age 5, why shouldn't they start creating on the computer as well and start creating their own interactive stories and games? So that was our goal with Scratch Junior, to enable kids, even as young as age 5, as they're starting to learn to read and write, to also be able to start to code. Because we really do see coding as a new type of literacy. The same way that reading and writing are literacies that you can use to help you learn and do many other things, we see the same thing with coding. That the same way when you learn to write, you can be creative in many different ways. When you learn to code, you can be creative in different ways. People often say that you learn to read so you can read to learn, and you learn to write so you can write to learn. The goal is not just reading and writing, but using your literacy to learn other things. We think it's the same with coding. We say it's not just learning to code, but coding to learn. So when we have young kindergarten kids like those in this picture, when they're starting to learn to code, they're learning important ideas. They're learning about sequencing. So here's an example of how they would create a project in Scratch Junior. It has many fewer words than in Scratch because the kids are just starting to read. So we do much more visually and graphically. But kids still are building up sequences of actions, and kids in kindergarten are ready to think about sequences and thinking about cause and effect. So those important kindergarten concepts of sequence, cause and effect, narrative, and storytelling are all things they can start to explore more fully through Scratch Junior. At the same time, they start to become creative designers, learning how to create projects, how to start with an idea and carry through to a project, how to break down a complex problem into simple parts, how to identify problems and debug them when things go wrong. So these are all things that are important in all types of design activities, and we found that coding activities like with Scratch Junior are a particular good way for kids to get started with creative design projects and to start learning about that creative process. By the way, this was just last month we launched Scratch Junior. It's now available as a free app on the Apple App Store. So if you go to the App Store, you can download this for your iPad. In the next few months, we'll also have a version for Android. Scratch itself is available in an online version. It works right in any browser. We're also working on tablet versions of that will be out before too long. In wrapping up, I want to return to this idea about creative learning. As we think about the idea of creative learning, we tend to think about creative learning in terms of 4 guiding principles that all start with the letter P. So we think about it in terms of projects, peers, passion, and play. So let me say a few words about each. We think if we want to help young people develop as creative thinkers, it's very important to take a project-oriented approach to learning. We don't want to just give kids individual exercises or problems for them to solve. Of course, solving problems is important. But what's more important is for kids to learn how to design a project, to start with an idea, to carry through with the project. There's lots of problem solving that goes on in the context of working on a project. And we see that if we really want kids to develop as creative thinkers, we need to get them engaged and work on projects. We know in our adult lives we spend so much of our time working on projects, whether at work or at home. If you organize a birthday party for a friend, that's a project. If you're organizing a family vacation, that's a project. We want kids learning how to start with an idea and carry through as a project. And that's one of the things we see as part of that creative learning process. But of course, projects aren't something you should just do on your own. So the second P is about peers. We see a lot of the best learning happens when you work together with others. That's why with Scratch, when we introduced Scratch, we introduced the online community at the same time, because you knew it was important for kids to be sharing and collaborating with one another. So the Scratch community both serves as an audience where when I create something, I can put it out there for others to use and other people to give me feedback. And we see that every day in the Scratch community, there are tens of thousands of comments that people write on each other's projects. So people are constantly getting feedback and advice from one another. At the same time that the community gives you an audience, it also is a source of inspiration. When you look at the Scratch Online community, you can see all of the projects created by others, and you get ideas from others. So this idea of working with peers is so critical to the learning process of getting feedback from others and inspiration from others. The third P is passion, because we've seen over and over that people do their best work when they work on things that they really care deeply about, things they're really interested in. We've seen over and over that people are willing to work harder and persevere in the face of difficulty if they're working on things that they're really interested in. And this is a real problem in many educational settings. In many educational settings, kids don't get to work on things they care about. And we've seen many kids who have been unsuccessful in traditional school settings are incredibly creative in other settings where they get to work on things they really care about, things they're really interested in. So we see it as so important. If we want kids to develop as creative thinkers, they need to work on things they're really passionate about. And the fourth P is play. And when I say play, it's not just a matter of having fun. When we think of play, we think of play as a type of approach to your activity. And when we talk about a playful approach, we mean an approach where you're constantly experimenting with new things, testing the boundaries, taking risks, trying new things. That's what's involved in play, and that's also what's involved in the best learning experiences and the best creative experiences. We want to let people be able to try things out. Creative things only happen, and the best learning happens only when you're willing to take risks. So we want to create an environment where people are encouraged to be playful, to try new things, and also to make sure that if something goes wrong, that it's a comfortable environment. They're not worried about being ridiculed if something goes wrong. So that's one reason that Scratch environment, we've spent so much effort to make sure that it's a very friendly, welcoming, productive environment. Because we know, it's not just because it's nicer to be in a friendly environment, but people aren't going to be willing to take risks and to try new things unless it's a very friendly environment where they know that they can, if something goes wrong, people will be supportive of them. So we want to be able to support playful activities by having a very supportive environment. So in everything that we do, as we develop new robotics kits like Lego Mindstorms, or developing new environments for programming and sharing like Scratch, we're always thinking about how we can support projects, peers, passion, and play. Similarly, when we set up new educational settings, like we have a network of after-school learning centers called computer clubhouses, where young people from low-income communities come and learn to use new technologies to express themselves creatively. When we set up these clubhouses, we think of them in terms of projects, peers, passion, and play. How can we set up an environment where kids can come in, work on projects in collaboration with peers, building on their own passions in a playful spirit? So we see that as the key to helping young people grow up as creative thinkers. And again, I think there's nothing more important in today's society. We know that people, whatever, today's, young people, whether they're in kindergarten or elementary school or middle school, they'll be entering a world as adults that's vastly different than today. That's the one thing we know for sure. We can't predict what it'll be like. And since we can't predict it, it's going to be so important for today's young people to be able to come up with new ideas based on the ever-changing environment that they're a part of. So hopefully we can support them through new types of environments and new types of technology we've been discussing today, so that everyone can extend that kindergarten approach through a lifetime, develop as creative thinkers, and be ready to be full and active participants in a society that will require and value creative thinking more than ever before. Okay, I think that wraps up the comments I was going to make, and I think we have some time left, and hopefully we can now take some questions from the audience. I wasn't very good at multitasking and looking at the discussion, so maybe Kelly can help me in pulling out some of the questions that people have been asking.
Yes, Mitch, if we scroll back up in the questions for Mitch area, there was a question on, in Ohio, we seem to be moving toward a test-oriented culture even in kindergarten. Suggestions on how to resist this trend?
Yeah, well, one point I'd make is when you say even in kindergarten, one thing that worries me is that although the traditional kindergarten was great for supporting creative learning, today's kindergartens do have much more. You go into many kindergartens today and kids are working on math exercises, doing phonics drills. Kindergarten is becoming more like the rest of school. And I think we need to do exactly the reverse. We need to make the rest of school and the rest of life more like the traditional kindergarten. At least for me, it's challenging to know how to make this change. I'm very optimistic for the long term because I think that society is changing that it will require creative thinking more than ever before. And eventually, our educational system has to catch up with the needs of society. When I mentioned going to Singapore, the reason I was in Singapore was because the government there had found out that even though that the students in Singapore were scoring at the very top of the international exams, like the PISA exams, that the industry in Singapore was saying that the students were not prepared for the workplace. Even though they scored so high on these exams, they would start in the workplace and they were good at doing very specific things they'd learned in school, but when a new situation arose, they didn't know how to handle it. So I was invited to Singapore by the government because the government said, even though the students are scoring so high on those exams, we need to change something because the students aren't really prepared for today's society. So I think we have to keep spreading that message that today's society, more than ever before, will require creative thinkers. And if we want to help develop creative thinkers, we need a different approach. It's not just about scoring high on traditional exams, but giving young people the opportunity to create and collaborate with one another.
Mitch, just a kind of a basic question. Will Scratch 2.0 be able to connect to the Pico board in the future? Scratch on the iPad, not just Scratch Junior. Any talk about that?
Okay, so with Scratch 2.0 connecting to the physical world, actually right now the Pico board that was mentioned is a specific sensor board that has different sensors on it that you can buy online. And actually right now we recently expanded Scratch 2.0 that you can connect the Pico board now on Scratch 2.0. If you go into the area of the editor that says more blocks, if you click on that, there's something that says add an extension. And this is one of the new initiatives we're working on. We're going to allow developers to build new extensions to make it easier to connect Scratch to many different types of devices. So it already now, if you go and use the current version, can connect to this Pico board sensor board. It can connect to the Lego We Do Robotics. But in the coming months, there'll be more and more things that you can connect to Scratch because we're opening it up to let more people add specialized bricks, specialized programming blocks to connecting to different physical devices, also to connect to online data sources. So one thing that'll be coming in the upcoming year is there'll be new blocks, for example, to connect to the weather data. So if you want to make a Scratch project with real-time weather data, there'll be blocks that'll give you access to the current temperature based on zip code. So these extensions will enable people to use Scratch to extend it to connect to many different things, both connecting to the physical world, but also connecting to the online world for all different types of data online, or different geographic data if you want to make a map showing different things online. All of that is coming with this new extension system. So if you go to Scratch, you'll see a couple extensions there now. There'll be many more of them. As far as the tablet version, right now only Scratch Junior is available on the tablet, but we're working very hard on a tablet version of Scratch. We hope to have a beta version of that out by the end of this calendar year, by the end of 2014. So if you keep an eye on Scratch and Scratch Ed, we'll be putting up notes about how you can become a beta tester, and we hope to have beta test, the beta test version of the tablet version of Scratch out by the end of this year.
And Mitch, what environment or languages are the extensions built in?
So for people, so again, they're not built in Scratch itself. It's intended primarily for people to build them in JavaScript. So it's meant for a developer who can then build these extensions in JavaScript, but then they can make Scratch blocks for other people to use.
Great. There's a question asked, educators need a lot of help connecting this kind of playful work to mandated student learning outcomes. What is the MIT Media Lab doing to help educators understand how they can work tools like Scratch into their curriculum and instruction and meet accountability mandates?
Yeah. Well, a few things. One thing I'd point to again is the work of my former student Karen Brennan, who's now a professor at Harvard Graduate School of Education, and we continue to work closely together. Like just this last month, Karen introduced a new curriculum guide that's called Creative Computing, and it uses Scratch as a core material, but it's not about just learning Scratch. It's about creative uses of the computer and different types of project-oriented approach. And in there, she makes all types of, she shows the connections to Common Core. There are examples there of, different types of assessment rubrics to connect it to different ways of assessing the activities. This grew out of a National Science Foundation grant that Karen and I had worked on along with EDC to come up with different ways of helping to share Scratch in classroom settings with educators. So both through the creative computing curriculum guide that Karen developed and also the Scratch Ed website, if you go on there, you'll see lots of examples that different educators have shared with one another about different approaches for both using Scratch and assessing the ways in which it's being used in classrooms.
And there was a couple of questions about Scratch being accessible to students with physical challenges.
Yeah. It's one thing where it's an area where we need to do more work because it's not we haven't done as much in the accessibility area as we might. We've heard a lot about kids in lots of different types of challenging situations using it. There's a slightly different question. We know that there's been a lot from the autism educator community has had a real interest in Scratch, and there's definitely a sub-community that's had a lot of interest in talking about ways of use of Scratch there. Also, some of the extensions to the physical world have been important in using Scratch with people, who face different types of physical challenges. So there are certain things there. Again, I'd encourage looking at Scratch Ed. You'll find some examples of different ways people are using it. But I think it's an area where there's more work that needs to be done to make it more fully accessible. With graphical programming languages, it's not as easy as text-based languages, for example, to make it really accessible for people who are visually impaired. That's an area that we'd like to do more work on as we continue to move forward.
And I'm walking through the questions right now.
Okay. Actually, I see there's another question that just came up about a teacher account. This is a very common question that we've been getting, because right now, when you sign up for Scratch, there's no special account for educators. That's something that we have been working on, again, in our group at MIT in collaboration with Karen's group at Harvard, making educator accounts to make it easier. Like some of the requests we've had from educators is if they have a whole classroom of students, rather than each student creating their own account, couldn't the educator just do a mass creation of accounts, like to make 30 accounts at once or 100 accounts at once? So those are things you'll be able to do from an educator account. Also, if you want to keep track of and make a gallery of all the projects made by students in the class, will make it easier to do things like that. So it'll make it easier to manage the work in a classroom. That's something, again, we had a Scratch conference in August, just last month here at MIT, and we showed some early of our mock-ups to people there, and later this year we again hope to have a beta version for people to start using.
And then, Mitch, do you see that last question about parents and their reaction to it?
Yeah. Well, again, I think, first of all, we've gotten a lot of excited reaction from parents who've been concerned when they've seen their kids only using computers in ways that they didn't see as so productive. And parents are very happy when they see their kids spending a lot of time on the computer, but doing something that they see as very creative and collaborative, as they see with Scratch. So we've got a lot of feedback from parents who are excited about this type of creative activity that their kids are doing with Scratch. Again, there's always a lot of questions about, especially with Scratch and the participation in the online community. A lot of parents who have questions about what it means to be participating in this online community and how we moderate the community. We have a whole collection of moderators. We have a couple full-time people and 8 part-time moderators that as things go up on the website, if anybody raises questions about it, we have moderators who will take a look at it. But it's not just for things that are inappropriate content, but also just if people are making mean comments to each other. We want to make sure that it's a very friendly, supportive environment in Scratch. So we spend a lot of time working on that. So parents who spend time, I think, also really appreciate that, the effort that has gone in to making it a very friendly, supportive community.
Well, thank you for joining us today. This presentation was fantastic. Again, this is the first in a series that is called Creativity is the Future. You can find us on social media at the hashtag #CreateEDU. And if you haven't already, you can check out other resources at the Adobe EdXchange at edx.adobe.com. And I'm going to drop a link. You can find out about more professional development series at that link posted in the chat. If you haven't already, we'd love for you to check out the Connect Ed initiative. This is for Title I schools. You can apply to have free software from Adobe. And again, the link is in the discussion on the left. And this is all for this afternoon or this morning or this evening, wherever you are. And we look forward to seeing you again in October. Mitch, again, it was fantastic having you online. This was just a wonderful presentation.